Moving ahead, let us talk about coating composition. Now, as I have told you, whenever you prepare for application of film coating, you have to prepare a coating composition, and this coating composition is sprayed with the help of the guns onto the tablet. The coating composition consists of film formers, which usually are polymers, which you are going to see in great detail in the subsequent part of my lectures. Pigments, which are colors, plasticizers, opacifying agents, and solvents. Okay. We are going to see each one of them in great detail. Let us talk first about the film forming agents. Now, film forming agents are divided into two types. You can have non-enteric film forming agents, or you can have enteric film forming agents. Okay, non-enteric film forming agents are used when you are doing non-enteric coating, and enteric film forming agents are being used when you are doing enteric coating. Let us start with the non-enteric film forming agents. Non-enteric film forming agents are of various type. There are various examples of non-enteric film forming agents. The first example is HPMC, that is hydroxy propyl methyl cellulose. These all are cellulosic derivative. Most of them are cellulosic derivative. Either they are acrylic derivative or cellulosic derivative. Okay. You have MHEC, that is methyl hydroxy ethyl cellulose. Then you have EC, that is ethyl cellulose. You have hydroxy propyl cellulose, which is HPC. You have povidone, and you have sodium carboxy methyl cellulose, that is SCMC. Okay, and you have acrylate polymers. So these are the different agents which are used in order to prepare a non-enteric film forming coating solution. Okay, so these are the film forming agents that you are going to use. Let us move ahead with the first film former. The first film former that is there is and very traditional use and very widely used is HPMC, that is hydroxy propyl methyl cellulose. As I have told you, these all are nothing but cellulosic derivative. So what you do is you take cellulose, and this cellulose is reacted with alkali. When you react the cellulose with alkali, the hydroxy group gets attached to the cellulose. So this hydroxy group comes from this alkali, that is sodium hydroxide. Okay, so cellulose is reacted with alkali in order to have hydroxycellulose first. Then this hydroxycellulose is further treated with methyl chloride, which gives it a methyl group, and it is further treated with propylene oxide. This propylene oxide gives this propyl group. Okay, and hence what you get is hydroxy propyl methyl cellulose. Okay, this derivative is being obtained. Now there are few things that you have to remember whenever you talk about the polymers. These are nothing but the polymers. Now whenever you talk about polymers, the first thing that you have to remember about the polymers when you are preparing a coating solution, that time you have to remember about the solubility. Solubility is very, very important. Depending upon the solubility, you categorize, okay, you categorize your agent as film forming or non-film, enteric coating or non-enteric coating film formers. Can anybody tell me very fast how can you categorize your film forming agents as enteric and non-enteric depending upon the solubility? Anybody fast in the chat box? Or you can open your mic and you can tell me a little bit faster. We have a lot of questions to come. How can you distinguish a polymer into enteric coating polymer and a non-enteric coating polymer? So I am distinguishing a polymer into enteric coating polymer and a non-enteric coating polymer depending upon the solubility. So that I am asking you how. pH high solubility is enteric coating polymer. Fantastic. Soluble at pH, yes, your answer is going with that bagad. Jivika, perfectly right. Okay, polymer that dissolves in acid is non-enteric. Fantastic. Great. Okay, Perfectly right. Whatever you have said is perfectly right. Now, non-enteric film formers are the film formers which dissolves into simulated gastric fluid, water, acids, okay, whereas they and other solvents. So these are non-enteric film formers. Whereas enteric film formers are the film formers which do not get solubilized into acid. It is not getting solubilized into acid. Okay. Film formers do not get solubilized into acid. Okay. They do not get solubilized into water. Right? They do not get solubilized into simulated gastric fluid. That is, they do not get solubilized into low pH. Whereas non-enteric film formers, okay, get solubilized into low pH. Right? So similarly, we are going to see the solubility of HPMC. Why HPMC is very widely used? Because HPMC is soluble in gastric fluid, simulated gastric fluid. What is simulated gastric fluid? The gastric fluid, the solution that is prepared outside, okay, in the lab, which is similar to the gastric fluid. So it contains everything. So you prepare this simulated gastric fluid inside the lab. Okay, and it is having pH, it is having content, it is having electrolytes, etc. Similar to that, it is present in the gastric fluid. Okay, so these are known as simulated gastric fluid. So HPMC is having solubility in simulated gastric fluid. HPMC is having solubility in water. It is having solubility in organic solvents. Okay, and it is having solubility in the solvents which is having low pH. Okay, in the buffers which are having low pH. Okay, and that is the reason why HPMC is very widely used. HPMC is another reason for widely use of HPMC is because it is non-toxic. It's very easily available. It is economical. It is compatible with most of the drugs that are there that are available. Okay, and that is the reason why HPMC is very widely being used. There are some disadvantages of HPMC also. HPMC and for that matter, most of the polymers that you are going to see further, they are having some disadvantages or the other. Okay, and that is why the disadvantage that HPMC is having, that it forms bridging and it forms rough tablet surface, and hence this HPMC is mixed with other polymers or plasticizers. These plasticizers we are going to see in the later part of the lecture. Okay. So one thing that I told you that you have to remember is about the solubility. Second thing that you have to remember is about the grades of these polymers. Okay, which grade you are using is very important. Okay, now HPMC comes in different grades. HPMC comes in HPMC 100, HPMC 1000, HPMC K4M. So various grades of HPMC are available. Okay, HPMC K100, etc. So there are various grades of HPMC that are available. The grades of HPMC depends upon the molecular weight of that polymer. Okay, so if the molecular weight is very high, then the grade is going to be higher. So HPMC 100, HPMC 100 and if you compare between HPMC 100 and HPMC 1000, then HPMC 1000 is going to have a very high molecular weight. What this molecular weight is going to affect? This molecular weight is going to affect the viscosity. Okay, HPMC 100 is going to be less viscous as compared to HPMC 1000. Okay, hence viscosity is hence grades are very important, because viscosity is going to be further very important. Okay, what is the viscosity is going to decide upon your quality of your film, and whether it is going to cause problem, whether it's not going to cause the problem. When we are going to see the problems in tablet coating, that time you are going to see that a viscosity plays a very important role. Okay, in order to form a proper film. Okay, so you have to choose HPMC of proper grade in order to get a proper coating solution, proper non-enteric coating solution. Okay, now moving ahead with the second ingredient. Okay, that is MHEC. It is nothing but methyl hydroxy ethyl cellulose. Okay, by now you know how it is prepared. You first alkali with cellulose, where you get this hydroxy group is been attached to it. Then you treat it with methyl chloride, where you apply this methyl group to it. And finally, instead of propylene oxide, which you had done earlier, now you treat it with ethylene oxide, and whereby you get this ethylene group attached to it, the ethyl group attached to it, whereby you get this compound as methyl hydroxy ethyl cellulose. The properties of HPMC and MHEC are more or less similar, because only propyl group is replaced with the ethylene group. Okay, so more or less the solubility etc. is similar. The only thing is MHEC is a little bit less soluble in the organic solvents. Okay, and it is not as frequently used as HPMC, whereas HPMC, as I told you, is very widely used. It is the first choice when you are thinking about non-enteric film forming agents. Okay, so this is something about MHEC. Moving ahead, okay. Now, whenever we talk about these polymers, whether you take HPMC, whether you take MHEC, whether you take ethyl, what do you call that, ethyl cellulose, further which you are going to see, whether you take povidone, okay, or whether you take acrylate polymers, all these polymers, as I told you, alone they are going to have some of the other problems with them. Okay, but whenever you use these polymers in combination, they are going to show a very good result. They are going to show a very good result in terms of solubility. They are going to show a very good result in terms of viscosity. They are going to show a very good term in formation of the film. Okay, they are going to show a very good term in flexibility, or they can show a very good term in terms of brittleness. Okay, for example, ethyl cellulose, which you are going to see further, are very brittle in nature. Okay, you understand the brittleness, isn't it? Mica, if you take in hand and if you crush it, it breaks. So that is brittleness. So ethyl cellulose is brittle in nature, right? In a similar manner, MHEC is also having some problems. Okay, it has problems in terms of solubility, etc. So that problem can be modified when you combine the polymers. Whenever you are preparing a coating solution, usually one polymer is not being preferred. You use multiple amount of polymers. For example, you can use HPMC, okay, which is a non-enteric polymer, and you can take HPMC phthalate or CAP. Okay, so what you do is you choose a non-enteric polymer and you choose an enteric polymer. What is going to happen? The modification of film is going to take place. Now the film which is going to be easily soluble is now not easily soluble. It takes time to solubilize. So what you have done is you have obtained a film which is having a modified release. Okay, you can have one non-enteric polymer with you can have another non-enteric polymer. Okay, so you have one non-enteric polymer and another non-enteric polymer, combination of these. Okay, you can have a combination of an enteric polymer along with one of the other enteric polymers and enteric film formers. Okay, so you can use multiple combinations. You can have one polymer with one grade, HPMC 100, okay, and you combine it with other grade, okay, another grade of polymer. So you do the combination of the same polymer with various grades. So when you do this, what you call that, maneuvering of the polymers with each other, combination of polymers with each other, what happens is you get a film which is having a modified film property. Okay, hence these grades are very important. Hence knowing the solubility is very important. In short, you have to know each and everything about your polymer. Okay, so one of the examples I have taken over here. Yeah, in this case, you are combining your MHEC polymer with propylene glycol, okay, and with cellulose acetate phthalate, which is the enteric polymer. Cellulose acetate phthalate is in short known as CAP, which you are going to see further. This CAP is an enteric coating polymer. You mix them together, and then you get different kinds of films. Okay, let us move further. Ethyl cellulose. Okay, now ethyl cellulose is manufactured. Now what you do is up till now you must have understood how the manufacturing takes place. you are manufacturing this cellulose. Okay, you first dissolve the cellulose with sodium hydroxide, and then it is reacted with ethyl chloride. Okay, and the ethyl group gets attached to the cellulose in order to get ethyl cellulose. Okay, this ethyl cellulose, as other polymers, are available in different viscosity grades. Okay, if you don't add plasticizers, okay, let me talk something about plasticizers, which we are going to see further. But plasticizers are the agents which provides plasticity to your films. Okay, your films become plastic in nature; they do not become brittle in nature. So, if you are using an unplasticized ethyl cellulose, so if you are using with your ethyl cellulose, if you do not add plasticizers, then your films are going to be very brittle in nature. Okay, hence it is very important whenever you are using ethyl cellulose should be used along with the plasticizer. Okay, or ethyl cellulose should be used along with polymers such as HPMC, etc. When you use them in combination with HPMC or polymers such as MHEC, okay, with these polymers, okay, then only you are going to get the films which are not brittle in nature. Okay, so ethyl cellulose is never used alone because they are brittle in nature. That is the disadvantage it has. So it is always used along with the polymers, or it is always used along with the plasticizers. Okay. Further, another property that ethyl cellulose is having, that it is water insoluble. Okay. Thus, it cannot be alone used as in tablet coating, that is non-enteric tablet coating. It is always used with the combined with the water soluble additives, as I told you earlier. Okay, the water soluble additive you can see is HPMC. Now, HPMC is very highly water soluble. Your ethyl cellulose is not water soluble. So, ethyl cellulose is used along with HPMC in order to get reduced water soluble properties. Okay, so if you want to reduce the solubility of your coating, then and HPMC is giving it a very high amount of solubility, then what you can do is you can use ethyl cellulose along with it, whereby you can modify the property of this film and you can make this film as a less water soluble film. Okay, right? We are basically used in sustained release coating, right? Let us move ahead with the next kind of a polymer, that is HPC. Now, HPC is prepared by treating you treat your cellulose with NaOH, you get hydroxy group, and then it is treated with propylene oxide. So you get the propyl group. So hydroxy and propyl group are attached to your cellulose, where you get HPC. This all, please remember, is given exactly in Latchman. So whatever is given in Latchman, the methodology is given in Latchman. So that's why I have taken these points from Latchman. If you are not able to remember this chemistry part, if you can skip this chemistry part, as such, it is not important from the aesthetics point of view. From the pharmaceutics point of view, this is not very important. But most of the questions, if you see in industrial pharmacy, if you see about industrial pharmacy coming in GATE, they come from Latchman. Okay, that's why I am taking this part also to make you understand how the polymers are being formed. Okay, and this reaction is usually done at high temperature and high pressure. So when you react this hydroxycellulose with propylene oxide at high temperature and high pressure, reaction will take place. Then hydroxypropyl cellulose. How is the property of the film? The property of the it is tacky. You get a tacky film. Okay. Hence, it is always used in combination with other polymers. That I told you earlier. Okay. That polymers are never used alone. They are always used in combination. How is the solubility profile of HPC? HPC is soluble in water below 40 degree. But uniqueness of it is, if you increase the temperature above 45 degree, it becomes insoluble in it. Okay, so it is soluble in water below 40 degrees C. It is soluble in GI fluid. It is soluble in polar organic solvents. Okay, and your non-enteric film forming agents. Okay, moving ahead, next polymer that is used as a non-enteric film forming agent is your povidone. It is nothing but it is a synthetic polymer consisting of linear 1-vinyl 2-pyrrolidone group. This is the chemistry of it, and it is a synthetic polymer which is being manufactured synthetically. Okay, so it does not contain any cellulosic group inside it, right? How is the film property? It gives you a very clear, it gives you glossy, and it gives you a very hard film when it is dry. Okay, it also gives you a tacky film, okay, which can be overcome by use of plasticizers or which can be used by the use of the polymers. Okay, moving ahead to acrylate polymers. Okay, these acrylate polymers are usually manufactured under the brand name of Ultrajet. Okay, so you must have heard about the Ultrajet polymers, and you must have also heard about the company Evonik. Have you heard of company Evonik? Did you attend the cosmetic conference that was there? Cosmetic conference, have you attended? Okay, so those who have attended cosmetic conference, they must be remembering. Okay, yes, it was in Naneshwar Hall. Perfectly right also, Isha. So at that time we had called a person from the company Evonik in order to give the lecture. Okay, Evonik is a company which manufactures Ultrajet. Okay, there's only one polymer. Just to tell you about a polymer and its important. And it is a multi-crore company. Okay, its turnover is about 1,000 crores. 1,000 to 2,000 crore company is Evonik. This Evonik is manufacturing only one polymer, and that one polymer that they are manufacturing is Ultrajet. Ultrajet with different grades they are manufacturing, and it is a 1,000 crores company. Okay, so that big is this company, Evonik, and manufacturing only one polymer. Just in order to tell you the importance of polymers, these polymers are not only used in coatings. These polymers, as we have seen, they can be used in nail paints. He came for cosmetic, whereby he said that Ultrajet can be used in nail paints also. This can be used for matrix kind of a tablet release if you want. It can be used in that. So these polymers are used in various places. Okay, so there is a high role of this polymer. Hence this part is being included into your syllabus. That is about the study of these polymers in coating. Right? Have you understood? So polymers play a very important role. Whatever are the novel drug delivery system that have been prepared. Okay, all your patches that you prepare. That is your buccal patch. Those are your transdermal patch. How are they prepared? These are prepared with these polymers only. These are prepared with your what you call that HPMC. They use sodium CMC, sodium carboxymethancellulose. They use your povidone. They use your carbopols, etc. Okay. Now these are the different polymers that have been used in order to prepare various novel drug delivery dosage forms. So if you are going to do your M-Pharm, then knowledge of these polymers becomes very important for you. So you have to take these polymers and you have to prepare a dosage form out of it. Okay, so all NDDs are prepared with the use of these polymers. Okay, you have seen when Viral gave that lecture on microcrystalline cellulose. A single microcrystalline cellulose is having so much of uses. He has shown there are so many grades and so many uses. In the similar manner, Ultrajets are also having different grades. There is a peculiar thing about acrylate polymers. Okay, these acrylate polymers, okay, manufactured and sold under the name of Ultrajet. Okay, they can be used as non-enteric film formers also, and they can be used as enteric film formers also. So acrylate film formers are used in enteric coating also, and acrylate film formers are used in non-enteric coating also. Okay, in both of them, they have been used. Different grades definitely. So use different grades in different kind of a coating. Ultrajet RL and Ultrajet RS, these polymers, okay, they are basically used for your non-enteric coating. Okay, so Ultrajet RL and Ultrajet RS, they are nothing but copolymers of acrylic and methacrylic acid. So you have acrylic and methacrylic acid esters, okay, and they are nothing but the copolymers of it. This is the chemistry part of it. Now the film produced are pH dependent and they show delayed action. Definitely, what is going to happen, what you are going to do is, as they are pH dependent and as they do show delayed action, hence they are coupled with your HPMC, MHEC, etc. in order to have modified film properties. the preparation is similar to ethyl cellulose formulation. Like you do for ethyl cellulose, in the similar manner you are going to do for your acrylate polymers. Okay. Now these were different polymers which were used for non-enteric coating. Now you have to use the film formers for enteric coating. So if I have to do enteric coating, then what are the polymers that I am going to use? But for doing enteric coating, first you should know that why should I go for preparing an enteric coated tablet? What is the reason for me to prepare an enteric coated tablet? Okay, there are various reasons. Okay, the first reason is in order to protect your drug. You protect your drug, which is acid liable, from the gastric fluid. So my drug goes inside the stomach, my tablet goes inside the stomach. The drug is present inside the tablet. Okay, it comes in contact with the acidic solution that is present inside the stomach, but it doesn't disintegrate there. From there it goes inside the intestine. Okay, and inside the intestine, now the drug is getting released. Okay, and now and in this way your coating is protecting this drug from the acidic environment. Okay, the second reason is in order to protect your gastric layer. So this is your gastric layer. This gastric layer is going to be affected because of your drug. It may cause nausea, it may cause irritation, it may cause ulcers. Okay, it may cause gastric distress, it may cause vomiting. This drug may be harmful to your stomach. So what you are going to do? You are not going to release this drug inside the stomach. You are going to do enteric coating to it. It is going to come inside the intestine, and over here inside the intestine, it is going to release the drug. So your stomach now is protected from the drug. So you protect the drug from the acidic environment, okay, and you protect your stomach also from your drug. In both the cases, you can do enteric coating. Sometimes you require the action inside the intestine. Okay, so for example, the drug like salazopidine, okay, which is being used. Salazopidine basically is used for your gastric ulcers. Okay, now salazopidine, if it is released inside the stomach, if you have intestinal ulcers, your salazopidine releasing inside the stomach is going to be of no use. It is going to get degraded over here by the time it comes down over here, right? So what we want local action of the drug inside the intestine only. So you release the drug inside the intestine. Okay. So that time also you can go for enteric coating. The another reason that you do for enteric coating is when the drug is getting absorbed from the intestine. Okay, to the maximum extent. Okay, in that case also you can go for enteric coating, where optimal absorption of drug is taking place inside the small intestine. Okay, and the small intestine is the primary route of absorption for that particular drug because of the pH, etc., because of the lining that is present. Okay, you have seen the pH, solubility, and absorption profile. Okay, you know it very well now. So if you feel that the drug is going to get absorbed optimally, maximum from the intestine, then instead of releasing inside the stomach, you releasing inside the intestine only. And or if you want release component for repeat action. Sometimes you want the drug to be absorbed from the intestine, stomach also. Sometimes you want the drug to be absorbed from the intestine also. In such cases where you want the drug to be going inside the stomach, after taking, you want the action to be showed after 3 hours or 4 hours, then what you do is you give it inside the stomach. Inside the stomach, the tablet is going to remain for 2 hours. Okay, then further the tablet is going to go inside the intestine, then it is going to release the drug, and say after 2 hours or 2.5 hours or 3 hours, the drug is going to show its action. Okay, in such cases also you can go for enteric coating. Let us revise why you go for enteric coating. First, to protect your drug from acid present inside the stomach, in order to protect your gastric lining from the drug. Okay, in to deliver the drug when you want to show the local action inside the intestine. Okay, at that time, For example, in case of antiseptics where there are ulcers, etc., you want to heal those ulcers. They are locally present. You don't want the drug to get absorbed in such cases. Okay, where the optimal absorption or maximum absorption is through intestine, that time also you go for enteric coating, or you can go for enteric coating where there is a delayed release of the, when you want delayed release of the drug. Okay, that time also you can go for enteric coating. So when you go for enteric coating, what you have to do is you have to use now enteric film forming agents. Okay, enteric film forming agents are also, they are also cellulosic based, but as we studied earlier, their solubility profile is different. Now, these enteric film formers are not soluble. They have a unique property. One property that they should have is, very important property that they should have is, they should not be soluble. Okay, they should not be soluble inside the acidic environment. अगर वो soluble होगा तो क्या हो जाएगा? Your tablet, when it goes inside the stomach, it is first going to get solubilized over there only, right? So it should be resistant to acidic solubility. Okay, whereas at the same time it should be soluble in your alkaline environment. So it should be non-soluble in acidic environment, but this polymer should be soluble in alkaline environment. When you have these properties, only then and then you can use these film formers, okay, as the enteric film formers, okay, for enteric coating. The examples that are there are CAP, that is cellulose acetate phthalate, a very widely used agent. Okay, whenever you see this group phthalate, okay, in any of the compound, please remember that this phthalate, whenever it is present, then it is always going to be a what you call that, an enteric film forming agent. Okay, the next are acrylate polymers. As we talked about, I told you acrylate polymers are unique polymers. They are used in non-enteric coating also. They are used in enteric coating also. Then HPMCP. HPMC is the same. That is, HPMC is hydroxy propyl methyl cellulose, and to it what is done is a phthalate group is being attached. So when you attach this phthalate group, this hydroxy propyl methyl cellulose, which is a non-enteric coating polymer, converts into an enteric coating polymer. Okay, and next is PVAP, that is polyvinyl acetate, and again the next compound that is attached to polyvinyl acetate is the phthalate compound, which converts it into a non-coating enteric coating polymers. Okay, moving ahead with the first one, that is CAP, cellulose acetate phthalate. Cellulose acetate phthalate is the widely used film forming agent in enteric coating. Okay, it is the problem that it has, it is a little bit hygroscopic in nature. Okay, and as it is a little bit hygroscopic nature, hence it is a little bit permeable to moisture. Okay, and it is a little bit permeable to gastric fluids also, right? Also, another problem that it is having is it is brittle in nature. So what you do is this, so these properties are not required. If I told you earlier only that this property, that it is permeable to moisture, it should not be your enteric coating film former should be not soluble in acid, it should not be soluble in water, it should not be soluble in gastric fluid. But it is little bit permeable, it allows little bit moisture to seep inside, it allows a little bit fluid to seep inside. Okay, and hence these CAP are usually combined with hydrophobic polymers, okay, which are having a very good film forming property for enteric film coating. So CAP along with other hydrophobic polymers, okay, they are going to give a very good film. Okay, this CAP, the solubility of CAP is near about in pH 5 to 6. Okay, in 5 to 6 pH it is soluble. Hence, these CAP releases the drug at the earlier part of the intestine. Okay, at the first level of the intestine. Okay, so hence as soon as the tablet crosses the stomach, in the immediately the polymer starts to degrade. Okay, the coating gets removed. Okay, and the drug is getting released. So it gets a very long time. So your tablet has a very long time, your drug has a very long time to get absorbed inside the intestine. Okay, In market, usually it is available as aquateric coating. Okay, this you get a solution of cap in the form of aquateric coating, which is nothing but a colloidal dispersion of the latex particle of this cap. So cap in market is available as aquateric coating. Now it is what is it? It consists of near about semi-solid or solid polymer spheres of CAP, and the colloidal particle it ranges from 0.05 to 3 microns. Okay, and if you take the average particle size in this aquateric coating of cap, it is near about 0.2 microns. Okay, so cap in market is available as aquateric coating. We talked about the problems of cap, but cap is very widely used because of its other property, its biocompatibility, its compatibility with the drugs, its solubility profile, its release profile, that it is released at 5 to 6, the various grades that it is available with, and the various forms, that is these forms, that's aquateric coating, etc. These forms that it can be manufactured into. Okay, its viscosity, and because of all these things, the positive points that it has cap. Okay, that's why it is very widely used in the case of enteric film forming agents. Okay, moving ahead with the ultrajet polymers, that is the acrylic polymers. Okay, we have seen that RL and RS, these polymers are used for your non-enteric film forming, whereas ultrajet L and ultrajet S, the example that was talked about. Okay, it was the example given was about ultrajet L and ultrajet S in that seminar. Okay, now ultrajet L, how it is, why they are enteric film forming agents? Again, because of its solubility. Ultrajet L and ultrajet S usually has the solubility at pH 6 to 7. Okay, at 5 to 6 solubility is having of cap polymers. Okay, whereas 6 to 7 is the solubility of your ultrajet L and ultrajet S. This L and S are nothing but the grades of these polymers. Okay, ultrajet L and ultrajet S, these are the grades. Earlier grades that we have seen is ultrajet RL and ultrajet RS. Okay, now how are they available? They are available as organic solution in the market. Okay, they are also available as solid or aqueous dispersions. Okay, they are also available. Ultrajet S is available as organic solvent, or it's also available as solid in the market. Right, as I told you, the solubility is near about at pH 6 or 7, that is inside the intestine. This is about the acrylate polymers. Moving ahead with HPMC phthalate, that is hydroxy propyl methyl cellulose phthalate. It is nothing but it is derived from your HPMC, and what you do is you attach your you do esterification with your phthalic anhydride group, and this phthalic group is getting attached to your HPMC. Okay, so it is derived from HPMC by esterification with phthalic anhydride. These are very stable than cap. Okay, CAP, the CAP should have been with a bigger font size. So these are stable than cellulose acetic phthalate, and it dissolves at lower pH compared to cap or acrylate polymers. So in the range of 5 to 5.5. Okay, these polymers are this HPMC phthalate gets solubilized. Okay, because of the solubility characteristic, as it is getting solubilized at the early stage of the intestine, hence they may have higher bioavailability. Okay, for some specific drugs, because you get much more time for the drug to get absorbed before it is eliminated. Okay, from the intestine, and it gets solubilized in the early part of the intestine. Okay, the available grades are HP55, HP50, etc. Different grades. When you're going to see your literature, okay, that time you will find different polymers with different grades. And how are they different? HPMC 55 is going to have higher viscosity. HPMC 50 is going to have a lower viscosity. Okay. Moving ahead, the next polymer that we are going to see is PVAP. Okay, polyvinyl acetate phthalate. Now, what it is, how it has been manufactured? It is manufactured by esterification of partially hydrolyzed polyvinyl alcohol. So you take polyvinyl alcohol, okay, you partially hydrolyze it, and then you carry out the esterification with phthalic anhydride in order to get polyvinyl acetate phthalate. the properties of this film are similar to that of your HPMC 55 in terms of salinity and in terms of pH dependent solubility. Okay, so it is similar to your HPMC phthalate